Welcome to Minimal Impact Design Standards Calculator Module 7, Swales. If you'd like to see other modules, you can go into the Minnesota Stormwater Manual and do a search on MIDS calculator videos, as shown here on the right, or you can click this link in Google or from the manual, and it will take you to the page showing the other modules. In this module, we're going to talk about the guidance and resources that exist for swales in the Minnesota Stormwater Manual. We're going to talk about 4 swale BMPs that are in the calculator: swale side slope, swale main channel with no underdrain, swale main channel with underdrain, and the wet swale. And then we'll touch back on guidance and resources in the manual. These are the 4 symbols that exist in the calculator, and we'll show those to you when we get into the calculator. So this would be the swale side slope, swale main channel, the swale main channel with an underdrain, and the wet swale. So I'm going to do an example for a swale here. I'm going to assume I have a half mile of road and the swales on each side of the road. So here's my road and the swale on each side of the road. On one side we have 3 acres of impervious, 5 acres of pervious on a B soil that drains to the swale. And on the other side we have 3 acres of impervious and 5 acres of pervious that are draining from a C soil to the swale. So at this point I'm going to exit out of this PowerPoint and go to the calculator. You'll remember that the calculator icon is this one here. You double click on it to open the calculator. We're going to open a new file. Go to File and click on New and type in whatever name you want. I'm just going to type in swale example. Click on Save, and the calculator will open for you. Now, remembering there are 3 entries that you need to make on this main screen to proceed into the calculator. First, you have to answer this question: are you using the calculator to determine compliance with a construction stormwater permit? We're going to say no for this example. We need to enter the zip code so we can access the rainfall data for your location. I'm going to put in 55155. And then our acreages. We need to put in some impervious acreage. If we don't have impervious area, then we have no volume to treat. In this case, if you remember, we had 10 acres of impervious. Yep. We also had 20 acres of pervious soil on C soils, 5 acres, I'm sorry, I'm getting these numbers wrong. Remember, we had 3 acres of impervious on each side for a total of 6 acres of impervious. We had 5 acres of C soil draining to one side of the road and 5 acres of B soil draining to the other side of the road. Now, this other material you can fill in if you want for your site, and some of these defaults here, the performance goal, phosphorus, and TSS concentrations are all default. They can be changed, and you can still operate the calculator. We're going to leave those as they are. So now we'll go into the schematic tab, shown here at the top, and you'll see on the left that we have this accounting. Shows us the number of pervious and impervious acres we have, plus our performance goal that we need to achieve. We haven't added any BMPs yet, so we haven't made any progress. We're going to have 2 swale systems, as I mentioned, one on each side of the road. So we're going to start by just clicking and dragging on the swale side slope, bring that onto the screen, and we're going to have a swale main channel and bring that onto the screen. So that's one side of our road. On the other side of the road, we're going to have a swale side slope, and it's going to go to a swale main channel with an underdrain, and that'll be for the C soils. So we'll start by clicking on the swale side slope on the site with B soils. Remember, we had 5 acres of pervious on B soils draining to 3 acres of impervious, and on the routing button shown here, we're going to route this to our first main channel. We'll go into our BMP parameters tab at the top here, and we'll input the information for this swale. We're going to assume the side slopes are 5 to 1, that your flow path length is 4 feet, the channel. So the flow path length shown in the illustration here is coming from your impervious surface down into your swale. And then the length would be the length of your channel, and we're going to make that 1,000 feet. So we're going to make that 2,640 feet. So this is a half-mile road, 2,640 feet. The underlying soil is B soil with an infiltration rate of 0.45 inches per hour. And the vegetation is going to be mowed turf. So we've got our swale side slope up. You can see that we're not getting any credit. The calculator, you do not get much credit for swale side slopes in the calculator. You can see now that the swale side slope is routed to the swale main channel. So now we'll go into the swale main channel. We're not going to input any acreages here because all of the acreage is already coming into the channel through the side slope. If you put in acreages here, you would be double counting. We'll go straight to the BMP parameters tab. Again, our channel length is a half a mile, 2,640 feet. The bottom of this channel is 3 feet wide and a swale slope of 2%. Let's go with 4 feet here for a width because we're going to put some check dams into this system. The underlying soil is the B soil with an infiltration rate of 0.45 inches per hour, and the vegetation is turf. You can see there are other options here. We are going to put check dams into the system. We want this to be an infiltration type BMP, so we'll answer yes to this question. And the check dams are impermeable. If they were permeable, we wouldn't get infiltration credits. So we're holding the water back behind the check dam and allowing it to infiltrate. And when I say, oops, I'm sorry, here we go with no. The check dam is impermeable. So now you can see that we have some values that we need to enter. So what's the top width of the check dam? So that would be the width that you wanted across at the top of the ponded water. We're going to say 7 feet. The depth of the check dam is going to be 1.8 feet. And we're going to put 20 check dams into this system. The drawdown requirement is for 48 hours. Now you notice that I put 1.8 feet for the depth of the check dam. If I put 2 feet in, I'm going to get an error message saying it takes 53 hours to infiltrate that 2 feet. We have a drawdown time requirement of 48 hours, and therefore we can't have anything more than 1.8 feet here. Another way to achieve infiltration in the system would be to put in a bioretention base. We're not going to do that in this particular example. So now I've got my swale completed, and you should see some information pop up here regarding the credits that are being achieved. Apparently the computer does not want to cooperate with me, but the numbers are there. You can find that out by going to the left toolbar and seeing what progress you're making here. Or you could go into the results tab and look at the information there. I'm going to move on to my second swale system, which is on the sea soils. And again, I've got 5 acres of pervious, but this is on sea soils. And we've got 3 acres of impervious. We're going to route that to our under drain swale, and then go into our BMP parameters tab and input the information for the swale side slope. It'll be the same information as we had for our other side slope, so 5 to 1 side slopes, flow path length of 4 feet, channel length of a half a mile. Now we've got an underlying soil, sea soil, 0.2 inches per hour, and it's on turf. And you'll see that this BMP now is routed to the swale main channel. I'll double click on the main channel. Again, don't enter any acreage. All of the acreage is being routed to the side slope first, and from there into the main channel. We're going to have a raised underdrain in the system. So I'll click yes here. And the channel length again, the same as before, 2,640 feet. A bottom width of 4 feet. A channel slope of 2%. And an underlying soil, a sea soil, 0.2 inches per hour. Our total media depth, we're going to set at 2 feet. And the depth below the underdrain, we're going to set at 0.8. Again, when we enter the drawdown time, which you'll see later, right here, I'll enter 48 hours. It wouldn't allow me to go above 0.8 inches. You get an error message saying that is too much water to infiltrate in 48 hours. Is the entire swale underlain by a retention base? We'll answer no to that, and we'll come back and answer yes in a bit and see if it makes a difference in our volumes. So it's asking me what the average cross-sectional area is below the raised underdrain. And so your entire swale is 2,640 by 4 feet. So if I entered 1,000 here, that's only 1,000 feet that we're able to infiltrate over. So if I went back now and answered yes here, you can see that that's how we block out the entire underdrain, the entire swale, just 2,640 by 4 feet now, as a bioretention base. So we're infiltrating over a much larger area. Field capacity minus wilting point, I'm just taking a middle value here, 0.11. And the same for media porosity minus field capacity. Again, these would be data that you would enter for your specific site. I'm going to use media mix A, and I'm going to assume it has a low phosphorus concentration. So I'll answer yes to that question, whether it has a concentration of P less than 30 milligrams per kilogram of soil. I'm not going to put an amendment into this particular practice. And so now I'm done entering information for this soil. I click on OK. And now I can go to the Results tab for the entire site. You see I'm out of the Schematic tab, or I'm in the Schematic tab, and I'm out of my BMP. And so I'm going to go to my Results tab here and take a look for my entire site. And you can see that I'm only achieving about 62% of my performance goal, getting an annual reduction in volume of about 67%. And so I'm not achieving my performance goal. If you go to the individual BMP summaries, though, you see that my swale main channel is getting about 94% of the performance goal. So it's coming very close. So it's the second swale with the underdrain where we're getting only 30% removal towards our performance goal, giving us a fairly low achievement here in terms of achieving the site performance goal. At this point, we would have to take this additional water and route it to another BMP if we wanted to achieve that performance goal, or come up with some other engineering scheme to get to that 1.1 inches if we want to. You see here on the Results tab, we're also providing information on phosphorus removal, particular phosphorus, dissolved phosphorus, and TSS summary. And you can see that my swale main channel with an underdrain is getting 94% dissolved phosphorus retention. If I went back to my Schematic tab and went into the BMP parameters, it asks this question about my P content being less than 30 milligrams per kilogram. If I had said no to that, in other words, I have a media that is high in phosphorus, I go back now to my Results tab, and you'll see that the dissolved phosphorus has dropped considerably, down to 47%. So if phosphorus is one of your main goals, you want to make sure that you have a low organic media, or that you're going to use an amendment, which, if you remember, was one of the questions that it asked, an iron-enhancing amendment to get a reduction there. Throughout the calculator, there are tabs that you can use to get at the Minnesota Stormwater Manual for guidance. There's a link here which you could click on, or you can click on the Help button. It will take you to a page in the manual called Requirements, Recommendations, and Information for Using whatever BMP you happen to be in. This one is swale with an underdrain as a BMP in the MIDS calculator. To look at the page contents, you can just hover over the page contents here and you can see that there's information on the methodology, how you calculate the volume reductions, the pollutant reductions, the routing, which we showed you an example of, some assumptions, and then some example, maybe one or two examples depending on which page you're in. And then some other information, including links to other MIDS pages. Going to the table of contents in the manual, you scroll down on this table of contents page, you'll see a link here to Minimal Impact Design Standards. If you click on that, you'll see guidance and information on MIDS, including the MIDS calculator. And in this link here, requirements, recommendations, and information for using specific BMPs in the MIDS calculator. If you click on that, this shows links to all the pages with BMPs, including the one that we just did, which would be swales with no underdrain. If I click on that, I'm back at the page that I was at just a little while ago. To view other modules in the calculator, you can click on MIDS calculator videos in the manual, or you can use this link to get at them. This ends Module 7, swales.